Hey, welcome everyone to this training session on PumasCP. Today we will be focusing on conducting a non-compartmental analysis for data from a single dose study. In the previous videos you have learned how to create a study, import a study and duplicate a study. You have also seen how to upload a dataset and perform basic transformations. Building on that foundation, today we will dive deeper into how to perform non-compartmental analysis using PumasCP. Let's begin by uploading our dataset related to a single dose study. Once you are on the study dashboard, click on Upload Dataset. From there, select IV single dose study data and open it. The dataset will be displayed in the web browser, giving you an overview of the number of subjects, time points for samples, and the data available. This visual summary helps you to understand the dataset you're working with. Once you confirm that your dataset is ready for analysis, click Done. The dataset will be saved and the time audit that is running in parallel helps you to identify recently revised datasets when you upload multiple files. Start a new task by clicking Run a new task. In the first step, you will define the task by giving it a name, let's say SD underscore NCA for now, which represents single dose NCA. The default analysis type, non-compartmental analysis, should be selected. Click Next to proceed to step 2, where you will select the dataset you uploaded. The timestamp will help you identify the correct file here. Next, step 3 involves mapping and grouping the subjects. PumasCP will automatically map the relevant columns such as ID, time, concentrations to the corresponding variables in your dataset. You can see that the plasma option is selected on the right hand side, which we will leave as is. And what is the difference between plasma and urine? How do we select or map the columns for these specific data types? We'll be talking in separate videos. The application has also mapped other variables like amount, route, and we will discuss options like sparse analysis mode and declaring LLOQ values in the further videos. You all know that NCA in any application or any data, all we have is these 7 steps. If everything looks correct and there are no errors in step 3, you can move directly to step 7 to review the NCA results. The application has already performed the analysis in the background, and you can view the results directly without waiting a minute. Interestingly, you don't find Run NCA icon anywhere in PumasCP. Here you can see that the NCA parameter summary table, parameter listing table is already generated for you. Now let's take a closer look at the steps in this process. Starting with step 4, we will review the input data. Here you will find the baseline demographics table, or in general we can call it table 1. You can also find a listing of concentrations at nominal time points. Also, the summary concentrations table provides a quick overview of your input data. In addition to tables, PumasCP also offers visualizations such as summary plots with means and standard deviations represented by error bars. You can also look at the observation versus time plots, which are stratified by the subject ID. These allow you to observe the individual profiles of each subject. Also, there are subject fits plots that are created using the adjust R square method, and you can see that the lambda z has also been computed based on that. So these plots can be observed just below summary observation versus time plots, and the exploration of subject based on these fits can be performed in step 6. Any table and figure in PumasCP can be edited and customized to your needs, which we'll cover in future videos. Moving on to step 5, you will find the NCA preferences, which function as the settings for your analysis. You can choose between regression methods such as linear up, linear down, or linear up log down depending on the nature of your data. For example, if your data exhibits mono-exponential decay, you might select linear up log down. And the threshold tab allows you to specify the number of data points to consider for lambda z calculation. For instance, if you enter 3 here, the last 3 data points of the plasma concentration curve will be used for this calculation. In step 5, you can also set rules for handling LLOQ, adjusting R square, and managing AUC extrapolation. These options are explained in detail in separate videos. Additionally, this step allows you to choose which parameters are included in the summary table. By default, exposure parameters are selected. You can also create custom parameters such as partial AUCs by providing specific time ranges or using subject-specific t-last. Finally, in step 6, you can explore the individual subject data and review the fits provided by PumasCP, which uses the adjusted R-square method to optimize the regression and calculate lambda z. You can click on each subject fit to perform additional actions such as excluding data points, editing terminal points by providing start time and end time, and you can also completely drop a subject. Click on Done to go back to the exploration page. Now clicking on Next brings us to step 7. Here we can review the NCA results. Apart from the NCA parameter summary table and listing table, you can also view the raw result file that is generated over here to look at all the parameter values of all the subjects. You can download this as CSV, arrow, or an XPT file. The raw result can also be downloaded in the structure of a PP domain. That will look something like this. We currently use the CDISC version 1.2. Now coming back to the task, click on Next to arrive at the View Results page, where you can review both the input and output data. Click on Complete to complete the task. You'll be brought back to the study dashboard now. That concludes the overview of non-compartmental analysis for a data from a single dose study. I encourage you to explore these features further and refer to the additional videos for more in-depth explanations. Thank you for joining this session.